Alright, we're going to get started. Thanks for your time, and hopefully everybody had a good lunch. Hopefully not too many carbs. We don't want to make anybody fall asleep with the carbo high. So, how have you guys enjoyed the morning so far in the course? Good? Everybody learned something? Okay. Excellent. Well, thanks again to Josh and Dan, and I wanted to also drop a plug. For anyone who's not already attending LASCON the next few days, this event is sponsored by LASCON, which is our conference. There's a discount code, rather than me saying it, it's on the whiteboard out front by the door, so if you'd like to get a discount and still come to the conference the next 2 days, if you're here at the same venue, we'd love to have you. As Josh mentioned, there's going to be even more talks like this with greater depth and a variety of different topics, and fun events, including a mimosa event in the morning, and a lockpick village, and lots of other cool activities. Capture the flag, badge challenge. What else do we have? Mechanical bowl, happy hour, free drinks. It's kind of a hard combo to beat. So with that, I'll let Josh and Dan take over, and hope you have a great afternoon. Thank you so much for joining us, and we hope you'll come back to LASCON. If not tomorrow, definitely next year, and join us for the OWASP Boston events throughout the year. Thank you.
All right, so well, Benton was talking about LASCON. It kind of reminded me of why James and I founded LASCON in the first place. We had another security conference here in Austin, and both of us had kind of gone there. We'd spoken at the conference and whatnot. And we've gone to a number of other conferences all over the place. And it was right after I had attended my first B-Sides Las Vegas Black Hat back in 2010. And for me, what I came to realize was that this is more information security, AppSec, OWASP, is more than just a show up, learn something, and then go back to your desk and do your day job. For me, this was really about establishing a community. And so when I became president of the OWASP Austin chapter, one of my key areas that I focused on is how do I strengthen the relationships between the developers, between the information security people, between the auditors. How do I get us all together and start talking the same language and start learning from each other? And so LASCON really was founded on that goal. It's a way to get the community all together in one place. We can talk a common language. We can learn from each other. So I really do hope that if you don't have plans on Thursday and Friday, you do join us for the conference. I can pretty much promise you it's going to be the most fun security conference you've ever attended. That was another one of our goals. We wanted it to be something where people went and they were like, damn, I had a good time. It's too bad it's over, So tomorrow, for example, before the happy hour, we're going to do our LASCON speed debates. And the speed debates is like, some of your favorite speakers up on stage arguing for things that they have no business arguing for and against. It's amazing. So we try and keep it fun, we try and keep it lighthearted, and we try and keep it educational as well. So I hope you all will definitely join us for LASCON. All right. So with that, we'll go ahead and continue through our journey, or continue with our journey through the OWASP Top 10. The next one up is number 4, Insecure Direct Object Reference. So, what is this? insecure direct object reference occurs when a developer exposes a reference to an internal implementation object, like a file, a directory, or a database key. And then without any sort of access control check to make sure that the user accessing it is actually supposed to be able to get at that, or some other form of protection, the attackers can then manipulate those references to access things that they're not supposed to access, unauthorized data. Help if I turn my clicker on. So the impact here is moderate. This is not going to be as significant as like the SQL injection, where we're just straight up pulling data out of the database. But these kind of flaws can compromise the data that's referenced by that parameter. So it's a little bit more scoped, but it's still pretty serious. Unless the object references are unpredictable, then it's easy for an attacker to access all the available data of that type. And this is really where things like the ORM tools kind of come in handy, because you're basically creating a situation where those references are effectively unpredictable, or they're strongly typed, and it's much more difficult for an attacker to make modifications like that. So in order to really determine the impact here, we have to consider the business value of the exposed data, as well as the business impact of the public exposure of this vulnerability. And that will be kind of a theme for most of these, because after all, data is king, and our impact is really going to depend on the type of data that gets exposed. So here's an example. I like to think of this as like a banking application. Banking is just so cool, right? Because there's all this money and all this information from PII, account information that's just sitting there, and it's ripe for the picking by some sort of attacker. So I like to think of this as something like that, where you've got these statements, right? And the statements are lined up in order from 1 to 12. This user has 12 statements under their account. And so in the normal use of this application, we would have something like, I want a view statement, and my statement is number 3, right? What happens now if, as a malicious person, I say I want 17 instead of 3? But the user is only supposed to have access to 1 through 12. So now they're asking for 17. Well, if 17 exists, and we don't have any check in place that says this user can only access 1 through 12, now that user is getting number 17, right? And they could access number 18, number 0, whatever the case may be, as long as we don't have any sort of restrictions, permissions preventing them from accessing that. That's where we have this problem. So testing applications for this can be difficult to automate again. And again, this has to do with the context that our scanning tools run in. They don't know what data a user should have access to. And because they don't know what data the user should have access to, then they can go through and they can say ID equals 1, 2, 3, 4, all the way up to 100, whatever the case may be. But unless there's somebody saying, yes, that's something they should have access to, no, that's something they shouldn't, this is just a logic issue, right? So that's why this is really, really hard for us to automate, but it's very important for us to test. And the way that we do this is we inspect the parameters that are being passed to the application. We then manipulate those parameters to see if we can get it to display something other than what we expect to display. And then we look at the pages whose only purpose is to display information about a single object. So documents, account statements. And I'll, I guess, give you guys a little bit of a story that I like to use in my training class when I'm talking with developers. Story from way back when. There was a website, and this company, their job was to put information up on this website having to do with the latest earnings announcements from the company and new stocks that you should buy and things like that. And what would happen is the company, before the official time that the press release was supposed to go out, they'd basically queue these documents up. And so they'd go and they'd write their little article about what this is, and then they'd say publish, but publish at this later date. Well, when they said publish, what the system would do is it would basically create a reference for that ID. And maybe it's a date that it's referencing, something like that. But once that reference was in the system, then you could actually go, even if they didn't publish an actual link to that, somebody, if they knew where to go, could basically hit like that date and see all the news information for that day. And what ended up happening is there were some, we'll call them entrepreneurs, who decided that, who figured this scheme out, right? And they figured out that on any day they could basically plug in that date and they could see the news. Even if it's not published yet, the data was there. And so when they figured this out, they actually started to do stock trading based on that information. And so they were able to see, hey, this earnings announcement is down, let's short that stock. Or this company's earnings announcement is way over what they had projected, let's buy a lot of this stuff, right? Because the price is going to go up. And I believe that those guys actually got charged with fraud as a result of this because they were trading with insider knowledge. So, lesson here, we want to protect that information. If it's something that somebody shouldn't have access to, we need to make sure that we're treating it as sensitive and that we're restricting permissions with access to that. So let's say I want to automate some sort of exploitation here. And let's say it's like that statement thing where the vulnerable parameter is an incrementing integer, 1, 2, 3, 4. It's really easy, right? I just say, hey, the integer I starts at 0, and I want a loop for forever. And I want you to get this page, and this is the parameter that I want you to put in. So in this case, the integer value. And then I want you to test the page and see what value you get back, and then just increment. And so what's going to end up happening is this test page is going to run over and over and over for each of the different values that I put in. In this case, it's going to loop to infinity. And then for each one, it's going to capture whatever that is. Maybe it's an error code. We want to see if that's a 200 page, meaning that the page is there, it was a success. Or a 400 error, meaning that it failed. Maybe I want to capture the size, because the size of the page return is indicative of the amount of data that's coming back to me. But in any case, I can use this to kind of go through and one-off, go through all the values. Kind of funny story around this, Matt Tesaro, who's doing one of our other training classes here, he's now an employee at the OWASP Foundation. And back in, I want to say it was 2011, I was in Washington, D.C. with him for the OWASP conference. And Matt was staying at a hotel. And the hotel basically used two things to authenticate to their wireless. Well, their wireless was a paid feature. So you had to basically pay in order to get wireless and access the hotel. And it required two things. It required your room number and your last name. And Matt knew that there were a number of other OWASP board members that were staying at this hotel. So he knew their last names. So it's a good place to start. And the hotel only had so many rooms, right? So we can basically go and we can say, all right, let's try the wireless with last name Cruz. Dennis Cruz was one of the board members at the time, or Jeff Williams or whatever. And then let's loop, right? Cruz and 0, Cruz and 1, Cruz and 2, all the way up to whatever the biggest room number is. Well, it didn't take long, and there's only 6 board members, 7 board members. So it didn't take a long time for Matt to loop through those and find a combination where this last name plus this room number equals now I have free internet access, right? So these are the kind of things that we want to protect against. We'll skip over that. So mitigations for this. The first is don't expose internal keys or identifiers. So if we have things that are kind of internal to the application, some account IDs or things like that, we should try not to expose those to the user. So we can create random identifiers and things like that, and by using the random identifiers, that means that an attacker, they're not going to be able to guess what the value should be. They're only going to be able to get this value or this value or this value because those are the ones that are presented. The other thing that we can do here is we can use object references that are challenging to guess. So like a GUID, for example, is a random identifier. It's something that you couldn't guess what that value is, and we can use that to track whatever it is that we're trying to track. And then the last item here is performing server-side authorization checks for object access. And this is really probably the most important thing, which is, yeah, we can try and do this kind of security through obscurity thing by randomizing the values that they're going to use to access it. and hope that nobody guesses it or nobody's able to brute force those values. But really the way to handle this is to say, you're logged in with this account, you have access to these things and only these things, and if you request anything other than that, we're going to deny it. That's really the way that we want to handle this. So to recap, insecure direct object references occur when an application exposes internal references to objects via parameters that are passed to the application. And to guard against it, we don't expose internal keys or identifiers. We use object references that are challenging to guess, random values, and we perform server-side authorization checks for any object accesses. Questions about that? No? All right. So there's some references, and then I'll turn it over to Mr. Cornell. Wasn't doing the preserve media.
All right. All right. So we're going to talk a little bit about security misconfiguration. And this is something that we've touched on a lot of, we've touched on this in a couple of areas. We've talked about these privileges, we've talked about defensive depth, and those are topics that have come up along the way, discussing things like SQL injection and other vulnerabilities. So we'll be covering some familiar ground in a little bit more specific and structured way. And this is also something that I think we are seeing become more important as organizations move toward DevOps. How many people here are doing DevOps? How many people are doing DevOps right now, right? So anybody deploying code to production right now? Good, that's DevOps is all get out. But it's long been a problem that we've seen in organizations where they deploy applications into environments that have poor security configurations and just poor security practices in general. And what we've seen in a lot of organizations that are moving toward DevOps is that's a great chance to get some things right that they were maybe getting wrong before, but it's also a great opportunity to get stuff really, really wrong. I was talking with our director of technology, and he was lamenting that with the wide adoption of object relational mapping systems, every developer now thinks they're a DBA, right? And things that traditional DBAs would do, like make sure that your tables are properly normalized and index things and whatnot, a lot of those get ignored until you have giant performance problems, until things are too late. And that's also what we're seeing now, that the infrastructure that application gets deployed on is now controlled by developers. Every developer is now like a junior sysadmin, with their Dockers and their software-defined networking and things like that. So especially in organizations where you're looking to make transitions to adopt more DevOps types of approaches, that's a great opportunity to get some of these good practices in place. So what do we do when we talk about security misconfiguration? So the security is not just, the security of the system is not just controlled by the application. Good security means that you have your application well written from a security standpoint, but it also means that you have your frameworks configured in a secure manner, that you have your application server, your web server, your database server configured in a secure manner. As an attacker, I don't have a need to take over the world via SQL injection, or I have a need for your data. And if I get that data via SQL injection, then that's great. If I get that data by using Metasploit to pop the database server box and I just pull the data from there, that's totally fine too. And so it's important to understand that these applications that you're writing get deployed onto an infrastructure that potentially has, or that likely has, vulnerabilities, and that at the end of the day, it's the least secure link or any secure link in the chain is going to be acceptable to an attacker as an attack vector for them to get into things. And so when you look at deploying your code, you need to look at the security settings and how those are implemented when you first set up the system, but also how they're maintained as the system matures and evolves over time. And also, and we'll talk specifically about components a little bit more as well, but the software needs to be kept up to date. That's the cool thing about security, is that it is always changing, right? You're fighting a human adversary, and human adversaries are going to adapt and get better over time. As a security consultant, that means I will always have a job. As a software developer, it means that unfortunately, or as a person who's fielding systems, it also unfortunately means that there's always going to be stuff to do. Right? They're never going to undiscover vulnerabilities in the Linux version that you're running. They're going to discover more vulnerabilities in the version of Linux that you're running. And so you need to keep things up to date. So the impact here, again, is moderate. These can be, you can have really, really bad problems that lead to serious compromised data. You could also have an impact where it's more information leakage and things of that nature. But this is something that, again, you need to pay attention to, because doing this wrong can allow, or can lead to pretty serious compromise, and recovery costs can be really expensive. Remember the story I told about my buddy in California, where they basically had to take their infrastructure, pull all the data off, slick it, and start over again, because they had a compromise. They couldn't figure out the extent of that compromise, so the only real solution was burn it all down and start over again. So, are you vulnerable with your systems? Are you vulnerable to security misconfiguration? And this causes you, or should put you in a position to ask a number of different questions. All right, is any of your software out of date? So you've got operating systems that are running all of these various servers. You've got your web and/or application server. You've got your database. Plus you have the applications that you've written, as well as all of the code libraries that are used to make that application do the stuff that it is supposed to do. And so a question is, how are you planning to keep track of whether or not these systems are out of date? You correct mailing list, you have patching, and other things of that nature. What are you doing so that when inevitably one or more of these components of the system go out of date, you're notified of that, and you can make a determination of how or if you're going to patch that. Are there any unnecessary features enabled or installed? Ports, services, pages in an application, accounts for an application, privileges for an application. Again, this is something where the big vendors have gotten a lot better. Does anybody remember like the good old days with Windows NT, or you installed Windows NT and it had like internet printing turned on by default, because why not, right? Leading to various worms and things like that. But that was their philosophy. Looking at, well, hey, we're trying to get additional system administrators to be able to stand up Windows servers. It wouldn't be easy. We just want stuff to work, versus all those unfriendly Unix folks. So we'll just turn everything on all the time with the expectation, or the statement. Maybe they don't really care, but the statement of, well, you should go in and turn off the stuff that you don't want. I would contrast that with the approach that the OpenBS defaults had, which was, we're going to turn nothing on. You have to explicitly enable anything that you want to run this system. And so, but as we've seen over time, the big vendors have shifted from a turn everything on and good luck to more of a, we want to be secure in our default configuration, and if people are going to reduce the security of the system, we want them to make explicit decisions to do that. Not everybody is doing this, but that's certainly the direction that we have gone as an industry. I don't think we're there yet, but I think that's great progress. Because again, if you really want to turn on internet printing on your Windows server, that's probably a decision that you should have to make. And you should probably have to stand up in front of your peers and tell them that you're making that decision, so you can suffer the appropriate derision and potentially change your behavior. Default accounts, their passwords still enabled and unchanged. The denial of service attack just last week with the IoT devices with the default passwords. So that's an important question: is how, when you provision new servers, how are you setting accounts and things? And that's something it can be a challenging problem if you are deploying VM images, Docker images, and things like that. There's a lot of value in being able to lock down configurations, and have that be done repeatably. Flip side of that is, how do you manage access to those so that you don't have a kind of a monoculture where everything has the exact same password. We've talked a little bit about this, but from a configuration standpoint, as well as from a logic standpoint, when your application encounters errors, how do you make sure that you're not leaking too much information out to the users of the system? And some of that is done via configuration. If there's an error, don't show the page with the stack trace and all that other stuff. But there are also decisions that you make as developers that also can impact this. So what do you report on a failed login? Do you say, hey, that's a good username, but the password is wrong? Or do you say, hey, I couldn't find that username? Or do you say, that username and password combination is incorrect? All right, in those first two cases, you're leaking information because of the way you're communicating the failure. You're leaking information to an attacker that says, that's a valid account, or it's not a valid account, or that's a valid account but not the right password. Versus in the second case, you're saying, you gave us a bad username or password, we're not going to tell you which, to try to log in. Also looking at the security settings of your development frameworks. Are those set to secure values? One of the cool things about the .NET framework is they had some built-in cross-site scripting protection, where they would look through and scan. Again, this is the negative type of input validation that they had. A couple of things that they would check for is very likely to look for potential cross-site scripting attacks, and they shut those requests down by default. I looked at one of the systems we were looking at, had that turned off, right? They had explicitly gone in and turned this off. And the question was, well, why did you do that? This is a nice little bit of protection you get. It certainly doesn't give you license to write a lot of cross-site scripting, but this is at least some protection you get in place. And their answer was, well, like sometimes we need to send XML in our request, and that was breaking. So we just, instead of being very focused in the way that we worked around that protection where needed, we just turned it off so that we didn't have to screw with it anymore. So, looking at the way you have configured these frameworks and the protections they have in place, is your application set up such that it can take advantage of those? And like the problem about this is that it's work, and it's work that in a lot of cases spans people's knowledge areas or spans roles, because what you're asking across the board with this configuration is saying, at the highest level, at the application level, hey, when you communicate about errors, are you revealing too much, right? Like that's not something you can automate the answer to that or have like a lockdown tool that says that. That's asking a question of like, are you communicating information that may be valuable to a user, talking about the business state of the system you're in? All the way looking at the configuration of application servers, the configuration of operating systems, the configuration of database servers, all of these things. And so this can be a challenging thing for organizations to get right because it crosses so many lines. It's not like you can go to your configuration, like you're the secure configuration expert, and let's just spend an hour with the secure configuration expert and they're sort of all this whole thing out. So that's the important thing to understand, is that these concerns typically cut across roles within an organization. So to get it right, you've got to get those folks to work together. So let's look at an example scenario here. When you install an application server, is the administrative console automatically installed, right? On a developer's workstation, that's probably cool because a lot of our developers, they have root access in a lot of cases on their workstation because they need to install stuff, do things and whatnot. Similarly, if they're installing a local version of the application server, they probably need that administrative access to go turn things on, turn things off, do whatever. But when you go to install to production systems, that's not appropriate. That you've got your JBoss admin console exposed out for everybody to access. Similarly, your default accounts. When you put things into production, do you have default credentials that are exposed out there and not changing? A lot of application servers, these administrative consoles have signatures that are pretty easy to figure out. Right? There are well-known URLs that you can go and test to say, oh yeah, well this is the JBoss server running this version, and this is the administrative console's turned on, and here's the default username and password. So that's something you need to pay attention to is, as you deploy your systems, the way that you build these images and deploy these servers, when you are looking at production systems, are you only deploying the stuff that you need? And when you're deploying this stuff, do you have some sort of procedure or control in place that forces you to change these, default passwords? Okay, a second scenario. You've got your web server, you're deploying code out to your web server, and you've got the web server configured such that it allows for directory listing. So if you go to a directory that has an index.html page, that index.html page is going to render. If you go to a directory where it doesn't have that type of page, the behavior of the web server is to list and say, here's all the pages that you can access underneath this directory. We see this in again in a lot of situations as well, and it's something that is pretty easy for an attacker to go and look for, and again, the type of thing that attackers can automate. And so from a configuration standpoint, when you deploy new web servers, how do you know that you've got the right web server configuration set up to not expose these vulnerable behaviors? Another great example is stack traces. If you're a developer writing code, it's pretty important or valuable to be able to see verbose information about errors. If you're writing code, you've got a problem with the system, it's great to see like, oh, okay, I know what the problem is, I didn't check for null, and that was the code that I was just working, right? Really handy. If you were looking at a production system, this is absolutely the type of stuff that you do not want to expose. Because if you can see a stack trace, again, language, frameworks, a lot of times versions. In a lot of cases, you'll get error messages that may have snippets of SQL queries and things of that nature. And so when you deploy production servers, you want to make sure that those are configured in such a way that if you have an error, you display a generic error page, not one that has a lot of information about the internal state of the system and the internal construction of the application. Again, there's no reason to give attackers help. They've already, there's probably plenty of vulnerabilities out there. You don't need to help them along in figuring out where the vulnerabilities are and how to exploit them. Another great example, sample applications that come with your Tomcat or whatever other server it might be. Those are probably not things that you need to deploy either, right? There's no reason for those to exist on a production system. Why would you have the code there? Because if there are vulnerabilities in those example applications, and if they're example applications, I'm sure they've been subject to lots of fortified scanning and red teaming and things of that nature, right? For the Java Pet Store or whatever stuff might be included with your app server. If these sample applications have security flaws, then attackers can potentially use those to compromise the server as well. So you can do a great job writing secure code, but if you have a bunch of other apps with security problems hanging off of your deployments, that may be all the attacker needs to accomplish whatever they're looking to attack. And so you want to make sure when you have production systems deployed, you have only the code that you want deployed to those systems. You don't necessarily want administrative consoles, you don't want default applications. You want the latest version of your application and only the latest version of your application running on that application server. So how do you prevent security misconfiguration? And the big recommendation here is that you need to establish a hardening process that makes it easy to deploy another environment that is properly locked down. And to the degree possible, you want your development, QA, and production environments configured identically so that testing on one is representative on testing versus another. That said, there are situations where you may need additional tools in a development environment, potentially in a QA environment, to do the appropriate diagnostics as you look to move code up through to production. And the process, again, to the degree that you can automate this to minimize the effort, that is going to help you. We've done a lot of work doing remediation of application level vulnerabilities. And an interesting thing that we noticed is, and we saw applications or systems where you could either, one touch, like redeploy the whole thing and make a new environment on Amazon because somebody had just spent some time scripting that up with Puppet, Chef, Docker, all the cool whiz-bang stuff. On the other side of the system, or on the other side of the spectrum, there's systems where it's like, nobody touches the production server because we're not sure how we'd rebuild it if we had to. Like, nobody knows what version of NSXML is required to run this application, so nobody goes near this server because they're afraid that we'll break everything. We actually in one case found at a regional bank, there was a Dell workstation under someone's desk. like collecting dust that someone like kept their feet on, that was required for them to provision new employees or deprovision old employees. There was some like weird function running on this machine. And, and if that machine were to go down, they would no longer be able to hire new people. All right. Scary. And so, so we see things all across the spectrum. And in addition to this being important for hardening, automation allows you to do things the same every time and to do those things much more quickly. And they also help you do things like fix vulnerabilities, because you can easily stand up in an environment to go in and make changes and verify those changes and whatnot. And so to the degree that you can push, and there are a lot of great technologies these days, Puppet, Chef, Ansible, again, the shift to DevOps, which is business-driven, looking for that agility, looking for that type of speed, those tools can also be harnessed to accomplish tremendous security good things for your organization. That's the tension that we see with a lot of kind of older school security folks, is like the idea of DevOps and moving that quickly drives them a little crazy. But we've also seen environments where people have taken advantage of the shift to use these tools to make sure that things get locked down the same every day, all the time, every time it's done. So that's what you need, is a repeatable hardening process to say, how do we go from nothing to having a new version of this system? How do we make sure that all of the configuration hardening that we wanted to do along the way got done and got done repeatedly? You also need to have a process in place to keep track of the changes that have been made available for the components of this system, and to be able to get those deployed into a production environment. And this is also something very important for code libraries. And again, that's something that we're going to spend some time looking at in depth. But what do you have in place? What kind of patch management do you have in place for your environments, so that you know when patches, when critical patches are available for servers, and that you have a process to say, yes, we know we can take this offline, upgrade it, verify it, bring it back, and roll it back into the rotation. Same thing with code libraries. Again, new vulnerabilities, like the count of security vulnerabilities that are known in the world is only increasing monotonically over time, right? We're never going to get rid of vulnerabilities. We're never going to undiscover vulnerabilities. We're only going to find new ones. And so over time, you need to understand that the code libraries you're using, obviously the operating system, database, servers, and so on, like those are going to have new vulnerabilities identified, and you've got to have a way to get these things up to date. Also looking at the architecture of the application and the system as a whole to provide separation between components. We've talked a lot about defense in depth, and that's exactly what we're talking about here, is how do we build the system as a whole so that a compromise with one part of the system doesn't have a catastrophic impact on other parts of the system. And you can do that, again, at an infrastructure level, shaping network traffic from the configuration level. And also, this is the type of thing in your production environments you need to be able to run scans and do periodic audits to make sure that what you think is deployed and the security state of what is deployed is in line with your expectation. So to recap, again, attackers are going to use whatever is available to them. Default accounts, unused pages, unpatched flaws in the operating system, files that are deployed that shouldn't be, directories that they can get reporting off of. Whatever facilities are available to the attacker, they're going to take advantage of that. Because at the end of the day, if I want to steal your data, it doesn't matter if I got your data from SQL injection or if I got your data from, like pulling a unencrypted backup and tape off of the back of the truck. Right? Whatever gets me to the data that I want is fair game. It's unsurprising for criminals that there's no, they're not like laser focused on one particular technique. And so you need to understand that application security and the security of the system, the application code that you're writing, those get deployed into systems. So you need to understand that from an operating system platform, from a web server, from an app server, the framework, and a custom code. Like all of those have an impact on the security of what you've ultimately deployed. That's one of the, I mean, honestly, for me, one of the cool things about working in application security is that as a discipline, it spans a number of different areas. So that's fun for me. What's dangerous, or the flip side of that, where it's inconvenient, is to do this right requires input from folks in a variety of parts of the organization and across a number of different technology stacks and areas of experience. So what you want is a repeatable hardening process, preferably as automated as possible, which these days should be very achievable given the great tool sets that are now available to support a lot of DevOps and Agile stuff. You want, to the degree possible, identical configurations between QA, Dev, and Prod, so that you can do testing on one and expect that to be indicative of the security state of others. The automated secured build process, that's something like looking at the security of the build process is something that a lot of organizations, even if they're looking at security in other areas, sometimes this gets ignored. The security of the servers that you're using along the way to build these artifacts before they get deployed. Process for doing patch management, tracking software updates, process for keeping track of the security state of the versions of libraries you have deployed with your application. You want a strong systems and application architecture to provide that type of segmentation and isolation where possible. And over time, you want to do scans and audits to detect misconfigurations, missing patches, and other things that may creep in. Any questions on any of that? Yes?
I have a question about the identical configurations in Dev and Prod. My experience with scanning is always fine. It's very open systems in Dev. They're closed systems in Prod. The assumption was that as it goes through the process, it gets loaded in Prod, that's part of it. And a Dev system need parts and still work.
That's a great question. Can you harden dev systems? So there's a number of aspects of this. A challenge or something that we see go wrong frequently if you have very open systems in dev and an intention of very hardened systems in production is a lot of times, if you're developing on an open system, you may be relying on features or capabilities, you may be relying on something to work in a certain way that when it gets pushed into production, all of a sudden you've broken that assumption, and the only answer is, well, we have to turn that production, we can't figure this problem out, we need to get this deployed, turn off that protection in production, and we'll sort it out later, which means never, right? And so that's the kind of challenge we see if you've got, trying to think of specific configuration things, looking at, application frameworks and things like that. So, you want to like train like you're going to fight to the degree possible. That said, in development environments, you are going to need, you are often going to need access to additional tools for diagnostics. You are going to probably want more verbose error messages in development versus being in production. Another area where we see a lot of trouble and it's something to pay attention to is handling things like SSL certificates. I don't know a lot of organizations that are buying, like for each developer gets like an actual SSL cert for their workstation. And so we see that a lot like mobile applications where in development they'll be maybe talking to self-signed certificates, and so you'll see the configuration will be accept that our SSL handshake is not going to be, or our TLS handshake is not going to work properly. But in production, you want to say, yes, I actually want this only to connect to https://mybank.com, right? And so that's a situation where you need to be able to, especially when we talk about automation and having a process, to know these are the differences that we had to have between development and production. Let's make sure when our production build of our mobile app goes out that it has, that it's compiled with these flags, it's compiled with XYZ, that it won't accept invalid TLS certificates and things of that nature. And so, that's kind of ideally you would want that as much as possible so that you could go in and do your most invasive testing in like a QA environment, and you assume, well, hey, we're going to assume that this is roughly equivalent to the production environment. The reality of it is, for like certain things, there are you're going to run into situations where you have those differences, and that's why it's important. Again, to the degree you can have a documented process, preferably an automated process, where you say set up a new production build and it's going to flip all the flags and say TLS handshake has to work, X, Y, Z, whatever. So, good question. Any other questions? Fantastic.
You're moving along. You guys still doing okay? Very quiet. All right. Okay. So let's move on. Let's talk about number 6 of our top 10: sensitive data exposure. What is this? Well, many web applications don't properly protect sensitive data. Things like credit cards, tax identifiers, account information, account IDs, health information, authentication credentials. And if they don't properly protect that, then the attackers can steal or modify those the weakly protected data. And using that data, they can do things like credit card fraud, identity theft, and other crimes. And as a result of this, our sensitive data deserves extra protection, right? And so this is where we start talking about things like encryption. Encryption can happen both at rest, meaning when the data is sitting in a data store, whether it's a file system, whether it's an entry in a database, as well as in transit. So as we're clicking submit and the data is flying over the wire from our client to our server, things like that. And we need to take special precautions when we're exchanging data between the browser and the server. Now the impact here is going to be severe because failure in this case is going to compromise all the data that we intended to protect. So once we lose the data, once it's out the door, it's game over. You start looking at like the Lockheed Martin cyber kill chain, the last step is data exfiltration, right? Once the data is gone, it's game over. So typically this information includes sensitive data like health records, like credentials, personal data, credit cards, things like that. And I don't remember if it's in this deck or not, but it's really important for you guys as a security company, as doing secure development, to make sure that you are properly classifying the data that you guys have. So when you look at what data is in your applications, you can very quickly look at it and say, oh, this application processes credit card data. That credit card data is listed as high business impact. Therefore, it's something that we say we have to encrypt. And oh, by the way, because that's high business impact, it means that we're not going to put that data on a SaaS provider or something like that. So having those kind of processes, those kind of policies in place are a really good way when you start looking at the data that your applications are processing to be able to determine what that impact is. And obviously the value of that data and the impact to our reputation if we were to lose it are going to be the biggest factors in terms of determining the actual impact here. That said, there's also legal liability if the data is exposed. So in the case of health records, we have HIPAA that basically says you can't share health information unless it's authorized by the user. This is the reason why when you go to the doctor's office and the doctor tells you everything about you, but they can't share you even the information about your spouse or your parents until they actually sign that HIPAA release for that. My daughter had some tonsil surgery about a year or so ago, and the doctor actually moved practices. He started his own practice, and he had to send us a release so that he could get the records from his old practice transferred to his new practice. That's how strict the HIPAA laws are now. And then we talked earlier about California SB 1386, where if it doesn't matter where in the world your company is, if you lose data, if you lose PII relating to a citizen of the state of California, you are legally required to report that information to the citizen and say, hey, we screwed up, we lost your data. And then PCI, it has to do with credit cards. In this case, if you have a breach of your credit card data, PCI basically says that they can take away your ability to process credit cards, they can fine you, a pretty significant amount of money if you're not PCI compliant. So these are things where we have to consider all these different ramifications of not properly protecting the data. So am I vulnerable to sensitive data exposure? Well, the first thing we have to do here is determine if the data is sensitive enough to require that protection. And so this is where I come back to that data classification policy. We look at the data that we're going to be keeping in this application. We look at the classification, where it sits in our environment, and then we look at what do we need to do to protect that. So I was on a call last night, actually, with our branch in Penang, and they're working with a vendor out of China to procure a certain application. And the very first question that I asked is, what data are we storing in this? You know, they have a SaaS application. What data is going in there? Because for me, my entire security conversation, how I'm going to treat this application and how far I'm going to dig into what this vendor is doing is entirely dependent on the data that's being stored there. Now, if they tell me, the information that we're going to store is just, some information about how many clicks people do on a web page, that's probably not really sensitive information. But if they tell me, we're going to take credit card orders from all the people who are buying this widget, and then we're going to, send them the products, whatever the case may be. Okay, credit card information. I know my data classification says that that's high business impact, and therefore I need to protect that by encrypting that information. So the type of data is really going to change the conversation that I'm having and the amount of effort that I put into figuring out what the security impacts are. So we have things like passwords, credit card numbers, health records, PII, and all those things. So to figure out if we're vulnerable, the first question we ask is any of this data stored in clear text long term, including in backups of this data, right? Because if that data is being stored, for example, in a database, then that means that there is a point of exposure there where somebody could access that data. SQL injection flaw being one possible way to get at that data. Likewise with backups, there have been situations, I can remember a specific university one offhand, where they basically had backup tapes went missing. And when the question was asked, were those tapes encrypted, the answer was no. And so they lost, remember how many 100,000 student records as a result of that tape box just going missing. And they don't know that somebody actually used that information, right? All they know is that there was a tape box, it went gone, maybe somebody went home and overwrote all those tapes and used it for their system. Who knows? People do silly things. The next question we want to ask ourselves is any of this data transmitted in clear text? And that could be internal or externally. Because if that data is being transmitted in clear text, then that data is being exposed. And we don't have a really good way, other than HTTPS, to say, did somebody listen to this connection between here and here? And if we think about how far our information travels, right? If I go to a website right now, from my phone or from my computer, it's not like that's going from my wire to the closet over there, right? That's literally going across the country, if not across the world, in order to get there. And do you know every single company that touches? Do you know every hop that's going to take? Run a trace route sometime when you are hitting a website and see how many routers that packet is going to cross, right? We can't trust everybody there. So we have to use things like transport layer security, like our HTTPS, to ensure that that data is safe and secure. And we still have to do this internally. I got on my soapbox earlier talking about how it's just as important to do HTTPS on that stupid form that you're using to do whatever internally. And it's because these credentials, the username and password that we have for our organization, this is sensitive information. And if anybody, if I have an attacker on my network, and I always assume that there's an attacker on my network, if they're able to capture my information, my username and password, regardless of the method, it's game over, right? They now have access to a privileged account on multiple systems, and they can use that to take the data and exfiltrate it. So we need to make sure that we're using strong transport layer security. We also want to look at encryption algorithms, cryptographic algorithms. because there's a number of algorithms now that have been obsoleted, meaning that as computing resources advance, it becomes easier and easier for an attacker to basically have the number of resources available that they can break those things. So good example is MD5 hashing. MD5 hashes at one point in time were considered to be cryptographically secure. A hash is basically when you take one value, run it through a function, and you get back a different value. And anytime you run that through a function, you're always going to get that value back, right? But there's no way to kind of reverse it. So at one point in time, MD5, which is a way of doing that, was considered to be a cryptographically secure way to do that. Well, now computing resources are such that that's not really the case. In fact, there's a number of different places that you can go online where you can just plug in, it's like a search engine. You plug a hash into the database, and it goes and it's like, there's your answer, right? Because it always computes one way. So all you have to do is just feed the dictionary in, calculate the hash for all these different values, and you have what's called a rainbow table. It's basically a lookup of all those things. So we want to make sure that all these old, weak cryptographic algorithms, they're not in our code. I saw a really interesting graphic the other day, and I wish I put it in the deck because it was pretty awesome. But it was basically, starts with TLS in the middle, and it was like, here's all the different transport layer mechanisms that you can use, and it was like, you know, here's RSA, and here's AES, and you know, all these different things, and then from there it kind of spun off, and it's like MD5 hash, and you know, SHA-256 and SHA-512, and it basically kind of spiraled out, and then they even used some cool color coding where it was like red for all the MD5 things, and you're like, okay, that's a good way to kind of visualize what the space looks like. It's a good way to see, okay, well, if I need this, then I use the green things, and you just kind of follow the path. I thought that was pretty cool. Crypto keys. So we want to make sure that our keys are strong, that we're using proper key management, meaning that our keys are being stored in a secure location, that we're using, you know, that they're being encrypted, things like that, that our keys are being rotated on a regular basis. Again, we talked about some of the session brute forcing earlier. Just as easily, you can brute force any sort of a key, so we want to make sure that those are being rotated on a regular basis. And then the last one here is browser security directives or headers. So there's lots of different headers that you can include as a developer in your application to make it more secure. One that I was thinking of earlier, just lost it. Jeremiah Grossman and Arsnake talked about a vulnerability called clipjacking. And clipjacking was this kind of thing where you can basically put like think of it as like an iframe on top of the page that you're trying to serve. And by putting this iframe layer on top of the page, they were basically able to capture the clicks that you're making. And so what they were able to do is have like any old web page that tells you, you know, click here, do this, whatever, and on the background, you're actually clicking on something else. So for example, it might be like a deactivate account functionality, or it might be a password change functionality. And so while you think you're playing a clicky game, you know, click the moles or whatever, in the background what's actually happening is you're clicking the right buttons to make this other application that you don't even see because it's a transparent layer do things that you don't want to do. Well, there's actually a browser header, basically a directive that you can give the web browser that says, don't iframe my page in, right? It's an clickjacking header that specifically says, when you load my page, it should not be in an iframe. Now that might break something if you're trying to create some weird proxy portal and you want that page to show up in that portal. It's going to break that because it's going to break out the frame, but it's also going to prevent somebody from doing something like that clickjacking. So these are things that we need to kind of be conscious of and actually take action on based on our situation. So here's an example scenario. We have an application, it encrypts credit card numbers in a database using automatic database encryption, but this also means that it decrypts the data when it's retrieved. So think in terms of like the guys who I was talking to last night, they were like, yeah, we use Microsoft Azure, and Microsoft Azure automatically does the encryption and decryption. Okay, Well, if it automatically does the encryption and decryption, that means that every time their application basically calls into the database, it's going to do the encrypt or the decrypt. Well, SQL injection is just another way of calling into the database, right? So if their encryption layer is based on that, then my SQL injection is going to pass that as well. So in the case of encrypting the data in the database, I probably want to do an application level encryption and then shove it through the MySQL or whatever into the database, right? Because I want to make sure that my application is handling the encryption decryption. That way a SQL injection doesn't bypass that. Here's another scenario. This was a great tool, maybe 5 years ago or so. It was called Firesheep. Firesheep was basically this Firefox plugin that you could use. And if you went to like a Starbucks or some coffee shop, you'd fire up Firesheep. And what it would do is it would sniff the network for anybody using certain applications, Twitter, Facebook, stuff like that. And when it saw that information go across the network, it would actually capture the cookie, capture the credential that they're using in order to access that site. And it was like, it basically was like, do you want to log in as this user? And all you had to do was like, boom, yes. And now all of a sudden you're logged in as that user. You're surfing Facebook like them, you're posting Twitter like you're them, right? And so Firesheep was really good in terms of proof of concept of showing the importance of SSL encryption. It basically told us that if we're not encrypting that data and we're sitting at a coffee shop and surfing Facebook or whatever, then anybody can steal that cookie. Anybody can be us. They can do that broken authentication and session management that we talked about earlier, and now they're logged in as our user. So fortunately, Firesheep kind of shone the light on this big problem, and since that point, Twitter and Facebook and a number of other companies have now gone to SSL or HTTPS by default. So they are, you go to http twitter.com and you're immediately redirected to https twitter.com, and this is the reason why. Little graphic here, just kind of showing what we're talking about. So you've got this user on one end, they're transacting with an application on the other end, and if they're not using HTTPS in order to interact with this application, then somewhere along the line, that attacker may be able to see that information. And that might mean that they've compromised another server on the way. It may mean that they're sitting in that coffee shop and they're able to see the traffic as it flows over the wireless network. It may be that they've compromised a router or something. But regardless of where they sit in that network path, if they're able to see the packets flying over the network and it's not encrypted, then they're able to compromise the data. Third scenario here, we have a password database that uses unsalted hashes to store passwords. So I talked a little bit about hashing earlier, and Dan mentioned that we don't want to store the actual password in the database, we want to store the hash value. Well, if all you're doing is writing that password through, let's say, an MD5 hash, which we said is not cryptographically secure, and we're storing that information in the database, then we can do what I talked about, the rainbow tables, and we can basically run through all the different password combinations. And now all we have to do is if we get that password hash, we just plug it into there, get back the information about what the password is, and now we can log into the website. And so this table actually shows you those MD5 rainbow tables. It's about 4,000 gigabytes or so across all of these different tables. And so, for example, if you're looking at the alpha space in 1 through 9 characters, then the size of that rainbow table is about 24 gigs, so relatively small, and you'll have basically 100% success rate at gaining that information, right? 1 through 9 characters. Most of our password policies, somewhere around 8 to 12, something like that. And it kind of goes up from there. You can see if we add, numerics, spaces, special characters, things like that. The size of those databases. But with computing power today, it's really, really easy for us to just say, here's all the possible inputs. Let's throw all those into, let's run through this hash function and put all the outputs there. Now we have that mapping.
This is without salting.
This is without salting. I was just...
That as practice that most people follow.
Yeah, and I was going to get to that. Well, I don't know about most people. I can't speak to that. But basically, what he's saying is that what we do to prevent this is we do what's called salting. And salting is basically for every user entry, In addition to their password, which we use to make this hash, we added a random value, and that random value is what's called the salt. And so for each user that we're trying to do this with, we basically create another entry that's our salt. And then when the first time this user uses this password, the first time they set this password, we take the password, we combine it with the salt, we run that through the hashing function, and now we have our hash. That's the value that we store in our database. And because we're storing that in our database, we don't have the actual password, which means that if our system gets compromised or something like that, they're not able to do that. Because we've added the salt value, it means that they can't even do this rainbow table thing because we have basically an entirely random value plus their password in order to even try and do this rainbow table thing. It becomes way, way more complicated to do a rainbow table with that. So that's the reason why we use salted password. Yeah. So most of the hashing algorithms that you'll see, the ones that haven't been obsoleted, like the MD5s, the reason why is because of the number of rotations that they do. So what you'll see is, bcrypt as an example, they don't just do this hashing thing once, right? If I take it through this function, and I take this and I put it here, that's really, really easy for me to do. And it doesn't take a computer a long time to do that, so you can whip through those combinations very quickly. The whole idea behind these these bigger algorithms, the SHA-512 and whatnot, is it takes more time to crunch through that. And so what they do to do that is they run it through that function, and then they run it again, and then they run it again, and sometimes it's upwards of 100 times, going through that process of running through that hashing function in order to get that final value. Yep, exactly. Yeah, I mean, when it comes to the hashing, you want hashing functions that are going to be slower because it makes it much more difficult for somebody to do a rainbow table or to try and brute force it. Yep. All right. Yes.
Where's the salt stored?
The salt is stored in the database. It's stored alongside the username of the database. The idea is that the salt is just a random value that you're able to append into that password. So you're not counting on the user. A lot of times users make poor choices when it comes to passwords and things like that, right? A lot of times those choices are based on things like dictionary words and stuff like that, which are easy to look up. A lot of times those choices are very short words and things like that. And so the salt is basically adding in some randomization, and we're not entirely counting on the user to give us proper values. It also means that when the attacker is trying to create these rainbow tables and automate that, here this hash calculates to this value, we're basically making it so that they can't do that. We've added this random chunk onto it, so they can't just go through the dictionary and here's all the stuff.
So even if they get salt, they can't use rainbow tables because they couldn't calculate it, including the salt.
Right, they would have to have the salt and the password, and they'd basically have to go through that exercise all over again, regenerating the rainbow table with that particular salt. And even if they do that, they only have one user, and it's a pretty slow function. Yeah, it's definitely possible. The goal of this exercise is more to slow them down than anything else. As long as you're doing your security right on the front end, they shouldn't be able to get that salt. But yes, absolutely. If they're able to get away to get the salt out of the database, now they have that piece. They still have to do. They still have to go through the entire dictionary, create that 4,000 gig rainbow table of all the different passwords plus the salt, and then hope that they come up with the right answer.
I have a question regards to that. So, Internet of Things, example, like Amazon has their security policies, and they have smart TVs, where I don't know what password is stored there. When you log into an private house, and you're passing insurance and
Probably. Yeah. That all depends on the vendor that's doing it and the developers that are working on it, which is the whole reason why we're here today, right? So Amazon may be hiring. Hopefully you can fix that, or Sharp or Samsung or whatever. I mean, if they were smart, right, they'd put like a TPM module onto the board, and then they use the TPM in order to do the encryption and things like that. But you could do hardware-based encryption. But yeah, I'm guessing that when you can buy this huge flat screen TV for $400, that they're not really worried about putting those kind of encryption chips and things like that into it. Yeah.
Definitely on that note, a lot of these devices pull the chips out. Very few will watch the
Yeah.
very historically, that's
Yeah.
kind of sad.
Well, I mean, these devices don't have a ton of computing power. It's like a Raspberry Pi, basically. It's nothing to it.
Yeah. Like the ring doorbell, all night, where you get this with access and doorbell, pull your flag, yeah, it's silly, but you have like Wi-Fi security cameras and some of those like swipe one. Now you have access to security cameras.
Yeah.
Yeah, and a lot of them don't really support more advanced authentication, like WPA2, any kind of like authentication breakers, they only support registration.
Yeah, interesting related note. So at one point in time, I was like, hey, I wonder if I can get my SimForce application to work on a Raspberry Pi. The answer is yes, I can. The challenge that I ran into was actually with the hashing function. The Raspberry Pi didn't have enough power and didn't have enough memory to really crunch through the hashing as quickly as possible. So logging into SimForce was something that probably took a minute, because it had to go through and do all that function. Once you're in, everything works just fine, because now you're just using that session credential. But getting past that initial login screen took forever, because the computing device wasn't powerful enough to do all that stuff. Yeah, other questions? Cool, all right, we'll keep going. The last scenario here is really just showing another pictorial. In this case, it's of the backups, right? So we have this scenario where somebody's interacting with the application, their sensitive information is being stored into the database, and then that information gets pulled out of the database and put into some sort of a backup. And if those backups aren't encrypted and they fall off the truck or they get stolen or whatever the case may be, now we have a scenario where somebody has access to that data. So this really points to why it's really important, if you're doing backups of sensitive data, that those backups are encrypted as well. The good news is that most of the modern backup utilities that we're using have the ability to use keys to do encryption of that data. And then it becomes an exercise in key management, how to control that key, rotate that key, things like that. All right, so how do I prevent sensitive data exposure? First of all, for all sensitive data, we want to consider the threats that we plan to protect the data from. Right? So we have to know what is the attack, what is the scenario under which we need to be concerned. And so, we contemplate, all right, is this an inside user, somebody who has access to our network, who has access to that system, things like that? Is this an external user because it's on the internet? And then based on that, we want to make sure that we encrypt all the sensitive data at rest and in transit in a manner that defends against those attacks. So we want to make sure that we're addressing those specific scenarios. The second one is we don't want to store sensitive data unnecessarily, right? And this goes for things like credit cards. It is a great example. If all I do every time somebody places an order on my site is take that credit card and store it in a database, take that card and store it in a database, eventually that database gets really, really big, right? And if somebody were to compromise that system, somebody were able to find a SQL injection file or whatever, and get access to that data, now they've got a huge history of all the credit cards that were used on my site. And some of these credit cards are valid for 2 to 3+ years, right? So the moral of this story is if it's data that we don't need, right? If it's one time to charge the card and then we're good, let's get rid of that data, right? Maybe we have a policy where sometimes we have to charge back the cards, we have to store it for that reason. Okay, cool, I get it. So let's do that for 2 months. Let's keep the card information there for 2 months, and then we delete the data. The idea here being that we have some sort of policy, some sort of process in place that when we no longer need that data based on whatever qualification that is, that we get rid of it. The third item here is ensuring that we're using strong standard algorithms and strong keys. Proper key management is in place. And the way that we determine what's strong and what's not is there's a standard called FIPS 140. These are modules that have basically been validated by the government as strong cryptography. And as long as we're staying in this FIPS 140, I think it's 140-2, as long as we're staying in that category, we should be in pretty good shape when it comes to cryptographic algorithms. If we start drifting outside of that, especially if drifting outside of that means that we're using homemade cryptography, we are entering a very, very bad place that I hope none of you guys enter. The fourth one here, ensuring that passwords are stored with an algorithm specifically designed for password protection. Gentleman up here mentioned bcrypt. There's PBKDF2, there's scrypt, things like that. But basically, we're using common standard algorithms to do the protection of those pieces of data. And then the last one here, autocomplete. If we have forms that are collecting sensitive data, and those forms do this autocomplete thing, which basically means that they're saving that information in the browser, then there are exploits that can allow an attacker to pull that data out of the browser. Dan talked about cross-site scripting earlier. There's a framework called Beef, the browser exploitation framework, and using Beef, you can actually pull this kind of data out of the browser just through a cross-site scripting code. So it becomes very, very easy for an attacker to leverage these kind of attacks. And Dan said, hey, this cross-site scripting is very focused on that browser. Well, think about how easy it is once you have control over the browser to now take over the user's computer. And once you have control over their computer, now you can control their network and so on. So these things that are seemingly pretty small from the beginning actually grow and morph into much bigger issues than they are there.
Do all the browsers honor the disable autocomplete?
I believe so. All modern browsers should. I don't know if you go back to like Netscape or something like that. That's about okay. Anybody run Netscape? All right, cool. Was it Windows 3.1 or something like that? Yeah, all right. Back in the day. Still running? All right. Cool, man. That's awesome. I remember when my dad got his first Mac Classic, there was a game I loved playing on there called Darkroom, and it was basically you just move the mouse and throw rocks at like bats that are flying at you and stuff. It's awesome. Good old games, right? All right. High-level safeguards here. I talked about this earlier, and good, I do. On my next slide, I actually have the example. Data classification policy, right? If you don't already have one, it's a great place to start. This gives us kind of the basis for our whole policy here. And then when we start talking with developers or the business or whatever, we can use this data classification policy and we can very easily point to, okay, this is the data, this is the type of data that you're talking about storing, this is the impact that we can serve it, here's the policy that says that we have to encrypt it or that we can't encrypt it or we do whatever, here's the piece that says where we can store this data, right? It's no longer just a conversational, I think we should do this, whatever. Here's our policy. This is what we feel should be in place. Would you like an exception? We can talk about that, but this is the standard company policy. We want to review the information stored in an application against that policy and determine what needs to be encrypted, and then we want to build or update our application to encrypt those fields at rest. So here's a sample policy. Very, very simple. It just says, we've created 3 different classifications. We've got high, medium, and low. For high business impact, we've determined that government identification, like driver's license, social security, passport, things like that, that falls in there. Personal financial information, so bank accounts and credit card numbers, health information, we're considering all that high business impact. And then our data classification policy would then go on to say anything high business impact should be encrypted. Then we've got our medium, which is sensitive information, race, religion, stuff like that, personal contact information, name, email address, things like that. And then maybe we encrypt that, maybe we don't. That's up to our company or our corporate policy. And the last one is this low business impact, which is publicly accessible web pages, white papers, things like that. And that's probably stuff we don't care about. That it's meant to be public information, so we don't really need to encrypt that data. But at the end of the day, we're making this very conscious decision about what data is and is not going to be high impact and whether it should or should not be encrypted. In terms of implementation level safeguards, we want to use strong encryption algorithms. FIPS says that triple DES is still okay. However, AES is the preferred mechanism for strong encryption. So if you're doing encryption, AES 256 is probably the way to go. Likewise, MD5 obsolete. I think SHA-128 obsolete. SHA-256 is recommended by FIPS as the hashing algorithm. We want to use platform-provided implementations of the algorithms. So this is the standard don't roll your own kind of thing. If the platform provides some sort of encryption implementation, we should take advantage of that. Primarily because if there's an issue in it, it's going to get fixed. Somebody's going to find it, they're going to report it, the application is going to get updated, and then we're going to have the latest and greatest available to us. In some cases, there might not be, and in those cases, we should look to reliable open source libraries, things that have been around for a while, kind of tested, tried and true. But even in those situations, we can run into situations where it's like Heartbeat. You had a vulnerability that was sitting in OpenSSL, generally considered to be very secure. It was sitting in there for a decade, right? And then the last piece is key management. We want to make sure that our keys are stored in a secure manner, something like a key store or another secure facility. In terms of Java, there's Java cryptography extensions, which basically is all the key information, the key store pieces. It's got the encryption algorithms, whatnots, JC key store, yeah. So to recap, this occurs when applications don't properly protect sensitive data. Can be prevented by encrypting sensitive data at rest and in transit. We don't want to store sensitive data unnecessarily, get rid of it if we don't need it, and then using strong encryption algorithms and keys. Questions? All right.
On the transportation services, trend not going to release locations.
Okay.
Is that something that is illegal to monitor? But if you do monitor, if you have access to PHI, passwords, fun stuff like that, and it's just that it's illegal to monitor, is there protection?
On pagers?
Okay.
Who uses a pager?
Personally,
Yeah.
Police,
Yeah.
some,
Oh, EMS, yeah,
some
doctors.
contractors for government agencies, some government agencies, military,
Yeah.
doctors, some machines will page things.
There was a really interesting presentation at Black Hat, I think it was the year before last, and what these guys did is they used a standard, I think it was like a TV card, yeah, and they basically started doing spectrum analyzation of it was like restaurant pagers. It was a really cool presentation. They basically looked at it, they were able to figure out based on this wave pattern or whatever, here's the bits that are actually being broadcasted. And they reverse engineered that back to this bit that identifies this particular device, and therefore if I flip this, I can access this device, and if I do this, then I can make all the devices go off at once. So these guys basically sat outside the restaurant and they were going, all right, let's make that one go off. And the thing starts buzzing and the person picks it up. They're like, okay, let's make that one. That one starts going off. And then they're like, all right, let's make them all go off. The restaurant's going crazy because all the things are going off. It was a great talk. Really interesting stuff. And it's
Some of the stuff when it comes to people not water encrypting their data, they'll just rely on TLS and everything.
yeah, absolutely.
You have devices that keys that are self-signed.
Yep.
You have to come out on your mobile ones.
Yeah.
But it'll just say whatever credentials in that. Hopefully you'll secure it. You guys tell someone else to secure it.
Yeah, the self-sign thing is another, I soapbox out it again. The self-sign is another really interesting thing because anytime we put one of those self-sign certificates out there, Dan mentioned it, there's a lot of dev environments where we use self-sign certificates. We're effectively training those users to click OK on what's meant to be a security word. The whole purpose of that self-sign certificate is to say that this certificate is either expired or it's a different domain than what we're trying to access here. And if we get that certificate warning, it means, danger, Will Robinson, there's a problem here, right? And the user should really think about it, think, okay, why is it giving me a problem? Oh, that thing's expired. Oh, they probably forgot to rotate it. Or, oh, that domain doesn't match. Hey, that's a big problem. But anytime you see that, that means that an attacker could have been right there in the middle. They could have changed the SSL certificate, and because the person is trained to just click yes, the attacker can be looking at that conversation. They can be seeing all that data there. So anytime you get one of those SSL certificate warnings, I urge you not to just click yes, but to take a moment, just pause, right? It doesn't have to be clicked right away. And think about why that message popped up. And think about, is this typical? Should I click this? Is this an application I trust? Am I going over the internet, or is this just my home server, or whatever the case may be? Because that could be indicative of a much bigger issue. Right? All right, step off my soapbox. Any other questions? Cool. All right, so I'm going to let Dan talk to you guys about missing function level access control. Oh yeah, great idea. So it is 2:17. Let's take a 10-minute break, so 2:27.